But, the studies show that when you tell people they don't have free will, like when you tell them about these neuroscience studies and then you test them after, they're more likely to behave unethically and to cheat on an exam. So the illusion of free will is actually very adaptive. We've evolved to have this very strong sense of our control over our own agency for a reason, because it helps us interact in social environments, right? If we know that we have control, if we think we have control over actions and we are responsible for actions, then we're going to behave in ways that are socially appropriate. If if you think, well, it doesn't matter anyway, my brain's deciding, I could just kill this person and say my brain made me do it, right? So the strong illusion of free will, it evolved it has a purpose.
I'm joined by the lovely Heather Boleyn. Heather, welcome to the show.
Hi, thanks for having me.
Pleasure to have you on today. Talking about your daughter's stickers just behind you. They look good. I think they really add something to the room.
Yeah, it's kind of like those cool tattoos that are like the little ones that are randomly, dispersed, and it's that cool kind of look. Yeah.
Is that the same thing that happens when you have a child? They just start adding little flavor of personality into all of the rooms all over the house?
Pretty much, yeah. They slowly take over your life, and that's symbolic of that. So, yeah.
I love it. So why don't you tell us what it is that you do? What do you spend your days thinking about and working on?
Okay, so I'm a cognitive neuroscientist and psychologist. And fundamentally, the kind of driving force in my career has been trying to understand the fundamental question of how the physical brain creates our subjective awareness. So basically the neural basis of consciousness. But then I also got really interested in the neural basis of all of these unconscious processes that are motivating our behavior, because much of what we do, the decisions we make, our behaviors are being dictated by things that are happening outside of our awareness, and we're only consciously aware of a very small bit of what's actually happening. We often make up these post hoc explanations about why we do things, which are not necessarily the real reasons. So, we have a narrative that we tell ourselves. So I'm interested in both the kind of how the physical brain creates our conscious experience and our subjective states, as well as the unconscious processes that are motivating us and explaining how we behave.
Wow. So we got a lot that we can delve into today. We've had a lot of discussions recently about sort of purpose and meaning in life and things like that. But I guess at an even more base level, the fact that we are able to be conscious, the fact that we're beings that can kind of consider our own existence sits before all of that, right?
Yeah, I think it was Carl Sagan who said we are a way for the, universe, for matter to know itself, right? Because it's basically matter that's organized itself in such a way that it can, have subjective states. It can try to understand itself and its place in the universe. It's pretty amazing. But it's very fundamental. When we talk about consciousness, we don't need language for it. We don't need a sense of self. It's really just pure subjective experience. So tasting something sweet, or, seeing the color red, or smelling a rose. And other animals have it. We, assume they do because they have similar hardware that we have. They act as if, for example, if you step on a cat's paw, it'll pull away and maybe yelp. It acts as if it's experiencing pain. We'll never know 100% for sure. But then again, I don't know that you're conscious, right? I assume you are, but so we just define it, basically consciousness as first person subjective experience. I just know that I have it. And even when we do experiments, the only way to really tell is the person has to report, did you see it or not? Were you consciously aware of that stimuli or not? They have to self-report. And we can make some predictions, with babies, where they look might be what they're attending to or what they're conscious of. But again, it's really this first person subjective experience that we're trying to understand.
So that's our definition of consciousness that we're working with today.
Right. Yeah. That's pretty much it. And then there's different levels, then there's then you add in language or self-awareness, and there are ways to sort of elaborate this subjective experience. But fundamentally what we're trying to explain is just how a physical piece of matter could produce this sort of subjectivity, these feelings.
Mm-hmm, mm-hmm. So how low down the animal kingdom does this go? Do we presume that insects are conscious? Is there a line somewhere that we hit?
Yeah, so there's been a lot of debate and discussion about this topic. It was a year or two ago. I was at a meeting which is all about animal consciousness. What do we know? And so, look, we can take it down to, a fish. A fish, for example, if you give it like a noxious stimuli, something that might cause them pain or that's, offensive, you'll see they might go towards the stimuli, then they get a sense of it and they'll move away, right? Something that, say, causes pain. But then if you give them something like a type of anesthesia that kind of blocks their pain receptors, then they don't move away from the noxious stimuli. So the idea with this is that they were feeling something, right? Because when you give them kind of an anesthesia, then they no longer retract from that stimuli, right? So we assume there's some sort of feeling there. And now how far down the animal kingdom, it's hard to say. And for this, we really need sort of a fundamental overarching theory of consciousness. So, for example, one theory that is pretty popular is called the integrated information theory of consciousness, which basically says that any system that has a high degree of integrated, differentiated information will have the property of consciousness. It's like a fundamental property of the universe, like gravity. So the brain happens to be one of those systems where, when we say integrated, it means like if one neuron fires, it will directly affect whether the neuron next to it fires, right? There's integration of information rather than, say, a pixel in your phone goes out, like it's not going to affect the one next to it, right? So that's not integrated. So we talk about high degree of integrated information. And so the brain happens to be one of those systems. And then basically there's a mathematical calculation called phi, which you can calculate the amount of differentiated integrated information of a system, and that predicts how conscious it is. So if we go along with that theory of consciousness, we can look at like a bee or, a fetus and try to make a measure of how much phi it has. And see, but under this theory, basically it's kind of panpsychic. It means anything like a light switch has a bit of information, right? It's either on or off. So in some sense, it would have a bit of phi. So it gets very like philosophical. So that's just one theory, So again, it depends on the theory. I think you have to have some sort of nervous system to have consciousness. Like, some people talk about plant consciousness and things like that, and I just don't think that they have necessarily subjective states or any kind of feeling. But I mean, I could be wrong. It might feel like something to be a plant that like responds to light and starts growing towards it. Yeah.
I think the sort of the anecdotal quote that I've heard from Sam Harris is that consciousness within any being is if there is something that it is like to be that being. If there is something that it is like to be a plant, or if there is something that it is like to be a bee, because we know with pretty good certainty that there is nothing that it is like to be a rock. Or like there's nothing really that it is like to be this table, apart from maybe when it was still alive, when it was a tree. But yeah, right. So is that kind of touching on what we're talking about there? Or is that coming from a different?
I mean, that's one way you can look at it, but some might argue that, say, the interactions, between the molecules within the rock, or have some level of, phi. I mean, there's different, levels of this argument.
Yeah.
And what does it mean to be like something? I mean, how would we ever know if it is like anything to be, let's say, a plant, right? So we don't know, because it responds to its environment. It might just respond reflexively, and we don't know that there's anything it's like to be that. So it's an interesting definition, but it's very hard to then test it, to then, prove, like, well, is it like something to be a bee? I don't know. How do we know?
Yeah. How much of your work is sort of theoretical and how much of it is experimental?
Well, I mean, all the experiments are based on some theory, right? So you have like a theory, and then you have a hypothesis, and you do the experiment. So much of it is trying to understand. I mean, I like to ask these big questions. When it comes to doing research, it's much more practical endeavor. And especially working most of my career at a medical school and Department of Psychiatry, a lot of it is, so as I say, some of my research is interested in that overarching question, but a lot of it is more practical in the sense of what's the neural basis of different psychiatric disorders, or in particular symptoms within psychiatric disorders, and how can we come up with novel treatments for those symptoms, whether it's impulsivity or compulsive behavior. So it's mapping out, doing sort of these correlations between underlying brain mechanisms and dysfunction, and then trying to kind of fix that either with drugs or cognitive treatments and the like. So that's more practical aspects of my research.
That's so fascinating that you've got this subjective experience, which is anxiety or happiness or depression or a thought pattern or whatever it might be. And the thing that kind of blows my mind is that the way that we feel something inside of our heads is one particular experience, but that actually manifests as something physically happening within the brain, right? It's a particular series of neurons firing, but we don't feel it like a series of neurons firing. We see an elephant when we think of an elephant, or we imagine a smell when we think of a smell, or we can change our emotional state when we think of that. That sort of the place where those two things meet, to me, seems so crazy.
Well, I mean, I think that's also why there's so much stigma around mental illness, because, let's say you, I don't know, you have like a bacterial infection. You're like, oh, there's this bacteria, I'll take this antibiotic and that will help it. Or you break a bone and, you take whatever to fix the bone. But when the brain is sort of broken or not working properly, we just don't see it as like a dysfunction of an organ. We see it as a dysfunction of a human being, right? And because it's just these subjective states, and people often forget that it's tied to a physical mechanism, right? So if there's a dysfunction in, let's say, your way of thinking, it's a problem related to the brain somehow. And we don't always know exactly how, but with enough time and research, we can figure that out. And then ultimately treatment can be targeted at the brain itself. I think talk therapy, like cognitive behavioral therapy and the like, does work because our thoughts can also work to change our brain. It's this interactive system. So you can either work sort of from the bottom up or the top down. But either way, it's both. It's just two sides of this same coin.
Yeah. So can you talk about some of the particular conditions that you think there's good opportunities to make inroads on treating people?
Yeah. Well, I mean, I think any disorder, whether neurological or psychiatric, there's always some room for improvement, or, people can change themselves. They can change their brain. Some disorders are a little bit more amenable to treatment than others, right? And it varies. There are individual differences. So, for example, personality disorders are a little bit harder to treat. In fact, much harder to treat than some other disorders, because they seem to be very fundamental and like very much, children who are born with a certain temperament you can predict kind of how their personality is going to be the rest of their life. And it's pretty sort of hardwired in, and much harder to change than, say, treatment for a phobia, for example. If you have, let's say, a fear of flying, there are certain like behavioral and cognitive techniques we can use to help treat that. And it's going to be pretty amenable to treatment in many cases. Whereas treating, say, like a narcissistic personality disorder is much harder to treat because it's just sort of part of your DNA. It's part of the way you're wired. But I do see a lot of potential right now in terms of novel treatments in the use of psychedelics, like psychedelic medicine to treat. So, for example, MDMA or like ecstasy to treat PTSD and other anxiety disorders, ketamine to treat depression, psilocybin or mushrooms to treat certain types of anxiety, and we're looking at other disorders as well, so including depression. So I think a lot of these novel treatments are pretty exciting. I mean, there hasn't been a lot of movement in the world of psychiatry for, I would say half a century, but we're starting to make some, except for like minor tweaks and things, SSRI. Okay, this is a little bit more selective serotonin one. This is slightly more selective, but, nothing really major breakthroughs. So I think we're at the precipice of making those big breakthroughs now.
I get you. So that would be really interesting to get your stance on psychedelics and how or why they work, because from a subjective experience, you take a particularly strong psychedelic, you have a subjective experience of seeing something, being somewhere, but what's happening neurologically at the level of the brain must be completely different. I don't know what's actually happening. So can you take us through what happens if I take a therapeutic dose of MDMA or if I take a therapeutic dose of psilocybin?
So it's different for the different drugs. So each drug has a different mechanism. And we're still in the very early stages. So there are different theories about why the different drugs work. One, let's say I'll take is psilocybin, which works on the serotonin receptors in the brain. But one thing that it does, as well as like LSD and other psychedelics, is it tends to, in a very general sense, open you up in many ways. So parts of the brain that are involved in your sense of self and your ego, you tend to kind of decrease in activation. So you tend to feel like one with everything, right? You get this disillusion of your sense of your ego. And a lot of these parts of your brain, like the prefrontal cortex, when they're really highly active or involved in like rumination and anxiety, or like when you're depressed and you have these thoughts that you just can't get out of your head, these negative thoughts. And this kind of helps break that cycle. It also helps you kind of we see a lot of novel activation across these long range networks in the brain, where a lot of the time there's a lot of local communication, whereas now it kind of opens things up. So you're thinking in a completely different way. But so there's a lot of, we can look at what's happening at the hardware in the brain, but I think a lot of the therapeutic effects of these kind of drugs is the psychological effect, because you only need to take it one or two times, like with guided with a therapist, for it to have this long lasting effect. Whereas other drugs, let's say an SSRI that you would take for depression, or a selective serotonin reuptake inhibitor, it always has to be in your system. Like it only works while it's in your system, and as soon as it wears off, that's why you have to take it every day, right? So there we're saying, okay, it's clearly the effect of the drug itself. Whereas with the psychedelics, it seems to be the psychological experience that's profoundly like shifts your consciousness or your perspective and has these long-term impact.
How do you, as a neuroscientist, look at that situation? I have a particular experience. I've not drilled or greased a particular thought groove a lot. I've not wrapped tons of myelin around one particular way of being. And yet, This particular experience has been so profound or changing that it's caused everything downstream to alter. What's that mean?
Well, what happened? Okay, so like when you're talking about, actual changes in the physical structure of the brain, you're talking about things like long-term potentiation, or like when you're learning something and you develop a new pathway in the brain, by like rehearsing it over and over again, right? And that doesn't seem to happen with this. But there is also something, called one trial learning. So like often this happens with something like a very negative experience, and it's adaptive because let's say, back in the caveman days, you're foraging through the forest, you get really violently ill by eating a particular berry, right? So for survival, it makes sense to like really remember that berry and that experience and never go near it again. Mm-hmm. So basically, you get sick from it one time, and that's all it takes for you to like avoid it. And, and we know that from now, like if you ever get food poisoning from something, you won't touch that food for a while, and that's adaptive, right? So you learn it. And so with the drugs, it seems like it's a very profound one-time experience, right? That might shift the way that you think about things. And then over time, that shift in your thought process will start to develop new pathways and new ways of thinking, right? But it's such a profound, it has to be like such a heightened level of experience, whether positive or negative, that it can really shift how you think, which then can go on to create these new long-term pathways.
That's so fascinating, the evolutionary basis for it as well. And it makes total sense. You've got this very, very intense experience. Like you either want to have it happen again, you find this unbelievable kill, or you come up with a new way of taking down a particular prey or whatever it might be. Or, the negative side, you do something that you don't ever want to do again. That's so cool.
I mean, it works. And so we're kind of like hacking into the sort of, caveman brain in a sense. And again, it can work, I guess, like when people have a traumatic experience, right, that also can stick with them, right? Something very negative happens. It's, in a soldier in war, and they see like their friend almost dies or does die, that can have such a profound effect that it causes all these negative psychological effects after. So I think with the psychedelics, it's trying to take that and having something very intense, positive, experience, that then sticks with you over time and helps change your brain in a positive way rather than a negative way, say with like PTSD.
Mm-hmm. So what about MDMA? Do you have an understanding of the reasoning for that?
So with MDMA, it's more about, and with the psychedelic assisted psychotherapy, which it's called, it's about, so often there's a sort of traumatic experience, like let's say with PTSD. And then our brain, we put up these kind of protective mechanisms because if it kept coming to the surface and we had to think about it all the time, it would be maladaptive. It interferes with our daily life. So we suppress it. But yet it goes on to affect our behavior, right? So, you know, we're anxious or hypervigilant or having nightmares, right? And one way to sort of resolve that is to gain conscious access of that unconscious memory that might be suppressed, let's say, and reintegrate it into the brain in a more neutral way. So it's not intimately connected with the negative emotion. So, you know, for instance, I don't know, let's say somebody was like sexually assaulted, you know, you could be able to like think about that assault and really think about it in your mind, but kind of separate it from the terrible emotions that it brings up. So with the MDMA, it's a way to allow people to remember these traumatic experiences in a neutral way, and in fact, in a way where they're feeling very calm and pleasurable, so that it can kind of reassociate these memories with more at least neutral emotions, so that they're not constantly, every time they're triggered, it triggers a negative emotion, right? So it's about kind of restructuring the brain and also allowing you to access unconscious processes that when you're in your sort of normal defensive state, you're not even allowed, that they don't even come to the surface, right? Yeah. So it's sort of a way to access the unconscious and then reintegrate the memories in a more neutral way. Yeah.
I keep on seeing so much about psilocybin, MDMA. You know, Tim Ferriss is donating tons and tons of money to MDMA therapy and psilocybin therapy because that's how much how much sort of future and how much efficacy he thinks is in these treatments. It's so mad that something that's a party drug that's seen as people as this kind of raver's drug from Woodstock or Creamfields or whatever it might be, to now be something that's potentially changing the lives of soldiers with PTSD or people that have got addictions and dependencies or people that have had traumatic childhoods. It's so crazy.
Yeah. Again, but it's not just, you know, it's with doing it with somebody who's trained to help you, let's say, gain access to these memories. I think just doing the drug itself without having that guided psychological experience doesn't have the same impact. So we're kind of using it in conjunction, you know, with the therapy.
Yeah. Or else everyone that was walking out of Creamfields or Ultra Festival in Miami would just be complete zen. Like absolute no inhibitions left. Everything would be working fine, right?
Everything great, kumbaya and everything.
Come to a music festival, get a brain MOT, come out and everything's working brilliant.
Everything's great.
So I want to kind of really try and dig into what it means that we have conscious experience, what it means that we can think of things and that we can remember things and that they appear in our consciousness. Can you kind of try and take us through how that is occurring within the brain?
So what it means to be conscious, or what? So
I'm able to picture something now. So I'm able to picture an elephant on my desk in front of me, and in my mind I can think of an elephant on the desk. I don't understand how my brain is able to make that elephant appear in my mind, or when I close my mind I can think of something which is a past memory. I don't understand how these particular processes, a bunch of synapses firing, actually creates a landscape or a sense of a smell or any of this sort of stuff.
I mean, to be honest, that is the big question, is why is it that these sort of neurochemicals slushing around and electrical impulses happening in these neurons can create these subjective experiences like the image of an elephant. We do know that, for example, so there's been a lot of work in the visual system in the brain, right? How we see something. And for example, when you see, say, a sunset, you know, we see a particular pattern of activation in the visual cortex of your brain. There's parts of the visual cortex that are involved in color perception and movement, and each like aspect of, let's say, a visual scene you're seeing, we can divide it up into different sort of segments within, let's say, the visual cortex or the visual stream, let's say, stream of information. And we see, and the reason I study, for example, people with psychiatric or neurological disorders is because it helps us gives us insight, like when something's broken, into actually how it actually works. Like, when your car is running fine, you don't really know, but when there's a problem, right, then you try to figure out, okay, is it the carburetor, whatever. I don't know a lot about cars, but, like when something is broken, you can understand how it works a little bit better. So like with the visual system, for example, some people get a brain lesion and they can no longer like see color, right? So they can see movement and but things are in black and white. Or there's another part of the visual cortex, if you get damaged, like movement is taken away. So they see everything in kind of like staccato. So like film, kind of like cuts, right? And so that helps us understand how it's all working. So we understand a bit about like when information comes into you get your retina stimulated, then we know it goes to like the thalamus, which is kind of a relay station in the brain, which then sends the information to the visual cortex, and then it's not conscious yet. Then it has to come back up through to the prefrontal cortex, and you need these kind of feedback loops until it comes into conscious perception. So we're learning about like what is happening in the brain when a certain stimuli becomes conscious. At the moment we're consciously aware of it, what needs to be in place. So we're looking at for the minimal, what's sufficient, necessary amount of activation for any conscious event to occur. What's interesting is that when you imagine, say, a sunset, you get the same areas of brain activation in those visual cortices as when you're actually seeing it. And there's other sort of circuits in our brain that signal to us whether that is coming in externally or being generated internally. So we understand the difference between imagining something or not. But certain people, let's say with schizophrenia, they lose that distinction. So they think, for example, the voices, which are really coming internally, like, you have that little voice in your head, but it's you, right? But they lose that distinction. So they think, well, somebody's talking to me, it's coming from externally. Or, hallucinations, it's really, normally, it's just my imagination. But when you lose that distinction, let's say you're on a hallucinogenic drug or you have schizophrenia, you think it's really out there, right? So our brain, it's all happening in our head, really. I mean, and what we perceive in our head doesn't necessarily correlate to reality. We're making these approximations all the time. Some of it, is better correlated than others. But it's all in our imagination, really.
Yeah.
Some of it gets primed by stimuli coming in, but it's still a recreation of what, we think is happening.
I'm reminded. I'm reminded of the example, was it a railway worker who accidentally had something shoot through his brain? And then I think there's another example. Yeah, there's another example of a man who killed his family and then went up on a bell tower shooting everybody. And it turned out that was because of a tumor that was affecting some area of his brain that encouraged aggressiveness. So I suppose that those are two examples. And your earlier example of someone who has a blockage that stops them from being able to see color, or stops them from being able to see movement, that you can pick apart the individual elements of how we consciously experience things, right?
Yes. Yeah. And it can change your personality. I mean, so you get like Phineas Gage, he had a metal tamping iron go through his prefrontal cortex, and he went from being a mild-mannered man to being impulsive and aggressive. You have the man who, killed a bunch of people when they found he had a tumor. There's another man who also, he was doing some sort of pedophilia-like behavior. They were about to put him in jail. He started getting these headaches, and then they found this big tumor in his prefrontal cortex, and then they removed the tumor and all the symptoms went away. He was allowed to return back home, but then about a year later, the symptoms came back, and sure enough, the tumor had come back. So, we're going from sort of correlation to causation, right? It's changes in your brain affecting who you are and how you behave. And now we're doing treatments like for intractable psychiatric illness. So basically where other first-line treatments haven't worked, something called deep brain stimulation, where we actually implant electrodes in people's brains in subcortical areas, evolutionarily older parts of the brain, and can change the behavior. We can help treat their OCD or their depression.
Wow.
So we're really starting to go in and manipulate the brain itself to change behavior, which is
mad.
great. Yeah, and we can control it with a remote control, outside
Oh my God.
your head. So turn it up, turn it down,
Wow.
Yeah.
Wow.
Yeah.
I think one of the questions that I'm trying to articulate here is that I'm able to see what I do with my body, right? Raise my arm, lower my arm. I also have that same conscious control over the things that are in my head, but I don't have I don't have control in quite the same way as I have control over my body. If I don't want to raise my arm now, it's quite easy for me not to do that. But if I say, don't think about an elephant, it's really hard for the person that's listening not to think about an elephant. Does that make sense? The fact that we seem to have much more control over the way that our body moves than what our minds think. Everyone that's listening will know what it's like to have heard a song earlier in the day and just be going to bed on a nighttime and it's just the chorus or like 2 lines from the chorus just nailing you as you're desperately trying to have some peaceful sleep. Mm-hmm. Do we have an understanding neurologically about why that's happening? Why it's so much more challenging for us to control our minds and our thoughts?
Right, than it is to, say, control a body part. Well, I mean, okay, so first of all, there are different circuits in the brain. No, I'm actually writing a book now about impulse control, how to control our impulses, our urges, our behaviors, right? So there are people out there who, for example, can't control body movements, people with tics, right? Tics disorder, where they have these uncontrollable urges to move, let's say, a body part, and they just can't seem to suppress that. So there are times when we have an urge to do something physically, but we are able to then suppress it. The brain is always active. It's always on, right? It's always humming away in the background. And, at certain points, thoughts pop up, right? And we can either kind of suppress them but we can't stop them from just popping up. And so the way the motor system works is slightly different, right? So it's not like randomly, like the arm will start to move or, we have more, it's sort of called like conscious volition, over that. But our thoughts are different. And so we can't, like I often say to people with, say, OCD, obsessive compulsive disorder, they have these obsessive thoughts they can't stop. Now, you might not be able to stop the thoughts themselves, but you can control the behavior. So usually you have an obsession, like I'm going to catch, like right now, there's the coronavirus, right? That's really scary. Somebody might be constantly thinking about it and anxious about it. And in order to relieve the anxiety, they wash their hands. But then they're washing their hands, 10 times a day. So part of the treatment is, well, you can control the behavior. You can't control the thought from coming. So when you have the thought, we have to not do the behavior. And over time, the thought will eventually start to subside because basically what you want to do is habituate to the anxiety. So when you wash your hands, you're basically getting rid of the anxiety and so the cycle keeps happening. But if you force yourself to sit with the anxiety, not wash your hands, eventually the thoughts will start to subside. So yeah, we have more control over our physical behavior in most cases than we do our thoughts, but we can control how we respond or react to our thoughts. And we can reframe our thoughts and, contextualize them and things, but it's very hard to just stop them from naturally coming up. And that's a lot of what meditation is. It's like allowing the thoughts to come up and just observe them and kind of be separated from them or a bit distant and not having to like emotionally react to them.
Yeah, I've had a number of discussions recently, one being with Aubrey Marcus about not fixating or suppressing when something arises. So that equanimity, right? That just allowance that it is and then it goes and then it is and it goes.
Right.
And that's certainly something that I know my friends who are significantly more experienced meditators than me sort of talk about enjoying on a day-to-day basis.
And one other thing, I was just going to say one other thing about that. The more counterintuitively, so the more you try to suppress it, the more it's likely to come up. So like with the elephant, if I'm like, don't think about an elephant, don't think about it, all you're going to do is think of an elephant. So the idea is to kind of, in a way, go into it, be like, if you're afraid of something, like, or you're getting anxious, like if you're about to have a panic attack, be like, okay, let's see, how anxious can I get? Is that all you have? Like, let's make it more. Mm-hmm. Because the more you try to not be anxious, the more anxious you're going to get. The more you try to not think of an elephant, the more you'll think of it. So it's like, let's move into it. Be like, okay, let's think about the best elephant you could possibly think of and all sorts of, ways to think of it. And after a while, you're just going to get so sick of thinking of an elephant, you're not going to want to think of it anymore. So it's like kind of counterintuitive how you have to stop suppressing in order to get rid of something.
Do you think that that's reflected when people have challenging experiences in psychedelic trips? So a lot of the time
Yes.
people will say, if you see a big snake or something scary, don't run away from it, run toward it. Is that a symbolic version of what we're talking about here?
Yeah, pretty similar. Exactly. Because the more you try to run away, the worse it's going to get. So you should just go into it, and then eventually it'll dissipate. Yeah.
So hilarious that you've got a symbolic representation in a psychedelic state of something which is much more common and usually traveled by people in a normal day-to-day state, right? You've got the thought that's coming up and you're running away from it, and that's actually making it worse. And now that's manifest as a dragon or a snake or a guy in a hooded jacket or whatever it might be.
Yeah, that's often what we do with kids, like with OCD. We kind of make a metaphor, like we'll call it the OCD monster, and like that thought is just the OCD monster coming, and you can't be scared of it. You just have to like confront it, and so it's kind of similar. I guess therapy with children is like dealing with adults on a psychedelic trip, although they do say, they do say that actually. There's this great work by Alison Gopnik, who's a child psychologist at Berkeley, and talks about the baby's brain, because the prefrontal cortex isn't fully developed until like you're 25, but that's normally what filters all the sort of random stimuli coming in because the brain's trying to make sense of it. But that being a baby, the kind of conscious experience of a baby is kind of like a psychedelic trip. It's very similar to that. Everything is just like, cool and moving. I've had, kids, and so I see it, like they look like they're tripping. They're just like, whoa, you throw something in front of their face and they're like, ah. So it could be a very similar analogy. Yeah.
Well, I think being around my business partner's kids, he's got a 3-year-old and a 6-month-old now. And I might not have said at first glance psychedelics, but I would have definitely said alcohol. Like he's just like a little drunk. Running around, Now he's a fireman, now he's bouncing off stuff. Yeah, just been crazy. And actually, to be fair, the last time that I went in, he just had a cookie, like quite a iced cookie, and apparently that just sent him through the roof. That was the MDMA hitting him. That was the child MDMA hitting him.
That's right. Cookies are child MDMA. Yeah, that's interesting.
Precisely what it is. So I want to get back to what we were talking about just before, where we said that you can have a thought arise which you didn't consciously come up with. So it's not as if you thought of your fear about the coronavirus, it just appears in consciousness. If it's not something that you've started yourself, where does that come from?
That's, and often a question is, where do thoughts come from? Where do they start? Mm-hmm. And it's really very hard to sort of find the initiation of a thought. Because as I said, the brain is always in flux and always in movement. So one sort of idea or kind of metaphor is that, this is basically taken from research which looks at brain activation and the rest. But basically, if you think of it like, the waves coming in on the shore, right? And they're coming in and like some are bigger, some are less, and at some point, like these kind of brain waves reach a sort of threshold just by the random fluctuations in activation in the brain. And when it crosses a certain, let's say, height or a threshold, that's when it suddenly comes into consciousness. So it's this constant random movement and activation, always like things fluttering around until they accidentally sum up to something a little bit greater that reaches a threshold, and then we become aware of it. So there's no sort of one place in the brain where it happens, but you can kind of think of it a bit like, this oscillatory firing of neurons, and at some point they sync up in such a way that it brings them up into conscious awareness. And so then we have this idea of like, we have control over the thoughts, but really we're just kind of like pushing the system a little bit in one way or the other. It's like a system that's already active, and then we have some control about where it goes, but often it's just doing much of it on its own. Sometimes we kind of steer or, control of it a little bit, but then it goes off on its own again.
That was precisely my next question. How much control over our thoughts do we have?
Yeah. It's a hard one.
I'm asking all the big questions today, Heather. Yeah, I'm really sorry.
God, I know you're going to push me this hard. No. I'm of two minds on this, because a lot of the research and the things that I'm interested in are like related to free will, right? And how much control do we really have? According to neuroscience, basically the brain decides first and we become consciously aware of that after the fact, right? We can see a buildup of brain activation. This goes all the way back to classic experiments by Benjamin Libet in the 1980s, where, he said, like, press this button whenever you get the urge, and then measured brain activation. And then you could see a buildup of brain activation about 350 milliseconds before the person was even consciously aware of their intention to move, right? And now with more modern neuroscience, we can see it up to 10 seconds before a person is even consciously aware, like, for example, whether they're going to go left or right, if they're going to make a decision on their own. So, I often say the brain, we don't have free will, but maybe our unconscious does. The brain is deciding, but you are your brain. And we're just the last to know about it. So in that sense, I don't think we have a huge amount of control. However, we have evolved the capacity to have self-control. So this prefrontal cortex, like the brake system in the brain. So we have this like urge to do something. And then maybe we have some forethought, like maybe that's not the best thing, to do right now. Like, I don't know, I want to like get naked in the middle of the street. Like maybe not a good idea, right? So then, not that I've ever had that urge, but other people.
Although you're among friends here, it's fine.
Oh, okay, I can let it all out. It's a private, this won't go beyond our conversation.
No.
So, but then, you have this, okay, maybe I shouldn't do that, and you'll suppress it. But some people, whether they have a brain lesion in the prefrontal cortex or underactivation or other kinds of psychiatric illness where they can't control that. So I do think that we have evolved the capacity to have self-control, even if we don't have like free will in the classic kind of philosophical sense, in that like, if everything was happening exactly the same way in your brain, you could have done otherwise, which would mean there's sort of a ghost in the machine controlling things. Mm-hmm. But like, no, I think the machine is controlling things, but the machine has evolved the capacity to have a bit of control over itself. So we do have some control in limits. And like also for people in therapy, let's say you're a really anxious kind of personality type. With therapy, I can get you to be a little bit less anxious, but you're never going to be the most relaxed person in the room. It's just, so there's movement within certain biological constraints.
That's so interesting. Luke, who is a friend that will be listening, I sent him Sam Harris talking about free will on Joe Rogan. I sent him this probably about a year ago from now. And it sent him into a 2-week spiral of depression because he thought that life was essentially meaningless. And I've never felt so bad. I was thinking about it last night. I messaged him today saying, hey man, how are you doing? Like, you in work tonight? Turns out he isn't. And I was thinking about it last night and I was like, I sent someone one video. It's 40 minutes. Sam Harris really shoves the red pill down everyone's throat about his view on free will. And it spiraled him into 2 weeks of depression. I was like, man, I am so fucking sorry.
Powerful, man. You got a powerful tool there. What tool when you're dealing with people's thoughts and emotions? I mean, it's like planting the seed, and then but the studies show that when you tell people they don't have free will, like when you tell them about these neuroscience studies and then you test them after, they're more likely to behave unethically and to cheat on an exam. So the illusion of free will is actually very adaptive. We've evolved to have this very strong sense of our control over our own agency for a reason, because it helps us interact in social environments, right? If we know that we have control, if we think we have control over actions and we are responsible for actions, then we're going to behave in ways that are socially appropriate. If if you think, well, it doesn't matter anyway, my brain's deciding, I could just like kill this person and say my brain made me do it, right? So the strong illusion of free will, it evolved it has a purpose. And when you break it, it can affect people. Although, listen, a philosopher once said this to me. I think it was John Searle, who's this well-known philosopher. Like, even if I tell you don't have free will, is it really going to change any of your behavior? It's not, because fundamentally the illusion is still existing, right? If I say like, okay, when you see something, you're not really seeing, it's just like these neurons firing in your visual cortex or whatever, you're still getting the perception of seeing the thing, right? So it doesn't change. So the illusion is still there. Even if I tell you about it, you get a momentarily like, there's a crack in your illusion, right? You like break the third wall, the fourth wall.
Yeah.
The fourth wall. But then you go right back, back to where you were before. So it doesn't last very long.
I've never heard that before. I've never heard that the subjective experience of having free will is fitness enhancing. And it totally makes sense. Heather, you've just completely blown my mind with that.
Great. That was one of my goals for this interview.
Wow. That's so cool.
No, just kidding.
You are totally right as well. And I mean, perfect example, case in point. Like, I told my friend, go and have a look into this free will thing. He did, and then he went down the rabbit hole of like every free will video on YouTube that he could find, went through the full works, and then has just come out as this complete, is it determinism? Is that the particular viewpoint? So now he completely subscribes to that. But you were right, he was like, he didn't want to go to the gym. He's like, what's the point of me going to the gym? I'm not going to go to the gym if I don't go to the gym. And you can totally see now, and it all makes sense. Wow, that's really, really cool.
Exactly. Yeah, I was just interviewed, there's going to be a documentary film coming out on free will. And actually my husband he's a rapper and he raps about science, and he's doing a rap on it about free will and the illusion of free will. And he kind of argues a way around it. Like there's like something called compatible determinism, and I won't even try to describe it because it's all philosophical, but it's sort of a way to kind of get us out of it a little bit. Like, even though everything's sort of determined from the Big Bang on, like there's some indeterminacy there. It's nothing to do with the also, let me just take this away for now. A lot of people want to talk about the, what is it called?
Quantum
physics.
States.
Quantum states, exactly. Yeah. I couldn't think of it. And because there's indeterminacy at the quantum level, whatever, like none of that scales up to like whether a neuron fires or not.
Yeah, so to interject there, I had Professor Sean Carroll on recently, who is...
Oh, I know Sean. Yeah.
So I had him on, and he said exactly the same as that you can talk about what's happening at the quantum level, and it, in theory, is how everything acts, but it's not at all how our conscious experience of the world exists. And the quantum uncertainty principle that we've got, it's not enough it doesn't create the special stuff to allow things to change in that way, which is what I think you're getting at.
Yeah, it doesn't scale up. So for instance, because we're living at the macro level of physics, right? Classical physics, not quantum physics. And so because basically it's an emergent property. So you have these things that are happening at the quantum level, but they don't scale up. So if we were living by the rules of quantum physics, we could disappear at any moment, like switch states, right? Like all of a sudden I'm here and then I'm not here, right? So that doesn't happen. So just because there's these quantum effects happening at that level doesn't scale up to the emergent properties of like what's happening at the classical physics level and like whether a neuron fires or not. So it's just not a way to, like, some people want to try to argue free will into that somehow, but it just doesn't work.
I think to the people that are listening, that are talking about what on earth are you talking about? Like, I've got free will. I can choose whether I put my right hand to the table or my left hand to the table. I have free will all the time. I can choose to think of an elephant. I can choose to think of the color red, or a memory, or a smell, or whatever it might be. I want to suggest? Right, I'm going to link the particular episode, the video of Sam Harris talking to Joe Rogan about free will. I'm going to link it in the show notes, but I'm warning you that if you decide to watch it, I'm not responsible for you going into a 2-week depression spiral. And also, Luke, I'm really sorry for telling thousands of people about the fact that I made you sad for a couple of weeks, man. We can laugh it off soon.
It's just, this is funny on so many levels. Like, who would have thought, like, you have to have like a trigger warning?
That's it. Yeah. Like, are you sure you want to open this link? Are you really sure that you want to open this link? Taking the red pill on that.
The red pill or not? Yeah, that's great. Like, warning.
Yeah.
You might be totally crushed. But the good news is it won't last long. Like, you'll go right back. It's such a strong illusion that you can't get around it. Like, that's what John Searle said to me. He's like, even if you know free will is an illusion, is it really going to change how you behave? And fundamentally, it's not. So the knowledge comes in and then it goes right back out again. You know, you have like a moment of like, wow, that's crazy. But then, you know what? It really doesn't feel that way.
You got to like operate, right? You just got to get around. Yeah. I've got stuff to do. I can't be thinking about the fact that I don't choose whether or not I do this stuff. I just need to go do it.
Exactly. It's like the example is like if you're at a restaurant and like what do you want to order? You sit there like, I don't know, there's no free will. Like, I can't, like ultimately at some point the brain just does what it does and it decides. And it's also like telling people like their sense of self, like self is an illusion. Like, it's a construct of the brain. There is no self. Like, it's basically like your brain when you were 3 is different than what your brain is now, but you still have this continuity, like, oh, that was me, right? That person at whatever 5 was me. But really, your sense of self is a construct. It's another perception in the brain that it's created by your memories and things. Like people who lose their memories, lose their sense of self. They don't even know who they are anymore, right? And there's all different sorts of disorders where people have, changes in their sense of self. So it's just another process of the brain. That's also an illusion. But again, it's so strong that we can't get away from it. There are moments like on psychedelics where you lose your sense of self and you feel disconnectedness, and it's a very powerful, very positive emotion, because a lot of our sense of self has to do with self-consciousness and worrying what other people are thinking and all of that. Whereas if you can let go of that, it can be very therapeutic. But
what does a prolonged sense of self look like in the brain? Is that particular neurons wired together? Is that kind of what it actually manifests as? It's a particular route of neurons that tend to wire together and fire together?
No, I wouldn't say that we found in the brain like a particular, pathway or, of that, like that's where the self is instantiated. There are a couple of key areas in the brain where we think our sense of self, and one has to do with our body awareness, like our sense, because it's our sense of self and also being a part of this body, right? And those are interrelated. So there's certain like key sort of hot spots in the brain where that help us form our sense of self. There's no kind of one place or one pathway. It's a lot of interconnected pathways that give us our sense of self.
There's a very famous British comedy show, and in it, one of the guys is talking about the fact he's had this broom for 20 years. I've had this broom for 20 years. And I said, 20 years? I can't believe it. Like, how have you managed to keep it for so long? And he says, yeah. Well, it's had 14 new handles and 13 new heads, but I've had this broom for the last 20 years. And that always makes me think about the way that our bodies refresh, right? I think is it 7 years? Within the space of 7 years, every cell in our body is going to have changed. So it'll have died and been replaced and then come back. And yet we are the same. But unlike the broom, for which that was definitely not the case, we are the same person.
Right.
Which is
but
so
are
mad.
we? I mean,
well, yeah, are we? I mean, I'm asking you. Heather, you are the person that is here to tell us whether or not I'm the same person I was 7 years ago.
There are parts of you that is the same person, but much of you is different. And so, in terms of neuroplasticity, in terms of the way your brain is changing, there are certain things that stay fundamental and stable, but who you are is really developing and evolving throughout your entire life until your very last day. Like I've said this, and I said this in my TED talk as well, like you're a work in progress until your very last breath. You're always changing, you're always evolving, you're always kind of redefining yourself and trying to figure out your identity. Like in psychology, they talk about all these different stages of development of your identity, but there's never really a point where it's like, okay, that's it, like we're done. It's never, okay, it's like evolution. We're all evolving as a species and we're still evolving, right? We haven't just stopped evolving. Like maybe in 1,000 years, we're going to be a slightly different species, or 2,000 or 10,000, however slow it's going, but we're still evolving. And that's just like within our own individual lives. We're still changing. If we meet again on this podcast in 20 years, which I'm sure you'll still be doing it in 20 years from now, we will, you'll be a bit of a different kind of a person. You'll have had different experiences. Your brain will have changed. So again, you'll have a perception of continuity, but how much are you really the same? I mean, it's an open-ended question.
It really is, because, especially a lot of people that go through big life changes and you think, well, the person that I am now versus the person that I was 7 years ago is so different that the only thing we both have in common is that we've both been in exactly the same spatial location between then and now, and we have memories from before that point. And that's it. That's all that you share with this person that used to be you.
Basically, it's a collection of memories. It's this memory storage. I mean, you should have seen me as a teenager. I mean, I have no idea who that person was, but I think it's still me because that's a memory set that I've carried with me.
But it could quite easily have just been someone else, right? It could have been someone else, but it wasn't. It was you.
Right. And it's really just because it's this physical package of, cells that are a collection of things that have, as you said, have changed over that time period anyway. They're not even the same cells. So it's just basically an instantiation of information that's been carried over in this kind of in our hippocampus, which is a memory section of the brain. That it's like, or I don't know if it's a CPU. I'm very bad at computer analogies as well. I have no idea. The RAM, I don't know.
Yeah,
anyway,
I get you.
You know,
it makes sense though. And is this? I'm going to guess that this will be fitness enhancing as well. To have this continual sense of self that allows you to kind of compound wisdom and learning over time. I remember I once did something that maybe wasn't so traumatic that it goes into the total change your perspective thing, but I once put my hand in the fire and the fire burned me. I don't want to do that again, etc., etc. Is that right?
Absolutely. Yeah. It's all, I think, some theories even about consciousness say it evolved because we evolved memory, working memory. So basically, keeping things online, there's a part of your brain called the dorsolateral prefrontal cortex, which is kind of like the working online memory, like when you are like remembering a phone number and you're saying it over and over again to like keep it in that space. And that when we had to sort of develop these recursive loops to keep things online, and it was adaptive, and that is sort of what helped bring us into sort of these conscious states as well, because you had a lot of this kind of recurring like information. I mean, it's one theory of how consciousness develops, but to be able to remember and not do the same sort of bad behavior or, learn where the tiger is hiding. And so, not to go there, or where you got the good kill. That's all adaptive. And then part of it is, it could just be as a consequence, we started picking up memories about ourselves, right? So not just about what's happening in the environment, but maybe internal states that we've had previously. I remember, how that person made me feel. Maybe I don't want to interact with that person anymore, but I think it's memory is certainly an adaptation that helped us to survive. And then came theory of mind, right? Being able to predict how you might behave or how you're thinking would give me an advantage, right? And so it's just another, a gift evolution has given us.
I had a William von Hippel on. Do you know who William is?
No, I don't know.
Bill von Hippel. So
I love that name though.
Oh, he's an absolute boss. He's such a boss. His book talks about Australopithecus and the move from apes in trees to upright animals on plains. And he talks about the development of the throwing arm. And he talks about theory of mind. And he talks about the fact that there's two examples that he gives. The first one is the first time that his son lied about something, and his wife was really upset that his son had lied and was like, no, like, Joshua, you're not supposed to lie. And secretly Bill was like kind of yes behind the scenes because his son had developed theory of mind for the first time. But the other thing that he talks about is this predicted requirement for tools in the future. So there's good examples that our ancestors didn't have this theory of mind because they weren't able to predict required needs. Let's say that they made a tool, used the tool for a particular purpose, then they would throw it down. But as we began to evolve and develop, these tools started to cluster together as opposed to just being strewn around. And what that suggested was you made a tool, you used it, and then you thought, in the future, I'm going to need this tool. I better take it with me. And I thought that was so interesting to have that happening.
The other, what's also interesting is basically it's because, can you still hear me? One of my things died, but you're okay.
You sound good.
We humans we have the largest prefrontal cortex compared to the rest of the brain than any other animal. And that gives us our ability to have foresight to think into the future. And so we can think further into the future than any other animal, which gives us a lot of advantages, but also disadvantages because we're the one species that can experience anxiety, which is different than fear. So fear is like, in the immediate situation, you're afraid, right? Fight or flight. Anxiety is the anticipation of a future threat or fear or right. And so that rumination, that anxiety, that the ability to think ahead, to think about our own demise, right? To contemplate our own death. Other animals are not really sitting there doing that. They're living in the moment, they're surviving. And, but we get this unique ability to have anxiety, about the future. But also, make these predictions like, hey, maybe I'll need that tool in the future. Maybe, other animals, and they might do it instinctively. A bird who builds a nest, they are planning for the future, right? A squirrel who stockpiles, nuts is thinking about the future. But, I don't know how abstract that is. You know, I just don't know if that's an adaptive behavior that they kind of do instinctively, or are they really thinking about like, man, you know, it might be a cold winter. I better, you know,
it's how conscious,
hunker down.
How conscious is that, or how much is it just North Pole versus South Pole and those two things clicking together? I think, you know, one of the things that I often think about with relation to my own brain is I've got this memory from ages ago when I was around an old girlfriend, and I remember looking at her dog and saying, I wish that I was Daisy. It would be so much easier and simpler if I was Daisy. And I was thinking, that's actually really profound to say that. It's actually really interesting to say, well, I would lose so much of the depth of the anxiety, of the depression, of the rumination, of the all this sort of stuff. But I would also lose the ability to be able to think abstractly, to be able to contemplate the fact that I am here thinking these thoughts. And I just thought, I mean, she didn't realize it at the time, and I've never told her, but, you know, fair play.
Well, you know, it's that ignorance is bliss. You know, sometimes I look at, you know, like babies or really young kids, and they're just fully in the moment, right? Their prefrontal cortex isn't fully developed. I mean, they're kind of like a cat. I was just talking about this last night with a friend, like, they could play peekaboo like all night long. I mean, it's endlessly exciting and never bored. It's always like a surprise, you know? So, or like a cat, you know, chasing a light, like it's just constantly novel. And so that's kind of fun, right? Dogs don't feel guilt, you know, these kinds of, or shame. I mean, they might act a little bit like we might anthropomorphize and think they are, but these very more complex emotions. And so, you know, I often wish sometimes I was just like, just as a human, like less, you know, I'm always thinking about these big questions, whatever, like, can I just stop and just, you know, chill out and, I don't know, watch the Kardashians or something and just be okay with that? But I can't seem to, so I think, you know, there's pluses and minuses, right? You can live in the moment, but I think that's what meditation does, is it kind of helps you to just be purely in the moment and try to release all the rumination and the anxiety and the thoughts about the future or the past and just be present and be kind of like a dog is really where you want to go with that.
That, to me, that sounds like a wonderful way for me to live the rest of my life. If I could just be as simple as a dog, that would be beautiful. But I also appreciate what you mean. Someone asked, I went to go see Jordan Peterson lecture in Manchester 2 years ago, sorry. And, someone asked a question, which was essentially, the depth of my consciousness causes me to suffer. That was broadly what the question was interpreted as, and it was the same as you. It was, is ignorance bliss? Like, can I scale back the depth of my consciousness and think about thinking less and think about things less? And Jordan gave it a very typically sort of symbolic answer, but what he said was, once you've opened that Pandora's box, there's no real closing it. Once you've realized the depth that your mind can go to, there's nothing that you can do to stop it. And he says the only choice really is to go deeper, not to go back, because there is no retreat. So he says, take more of the thing that poisons you until you turn it into a tonic and girdle the world around it. And I was like, I mean, it was real grand and metaphysics, like the way that, like classic Jordan Peterson. But I actually really liked that. I thought, you know, when we're talking about the crisis of overthinking, the crisis of worry and concern and anxiety. And what did you say right at the beginning when we were talking about something you have a fear over? It's like, I have my worry about this particular thing. It's like, right, okay, I'm going to lean into it. I'm going to completely immerse myself in whatever this thing is and break it apart into its component pieces. What are the actual fundamental parts that this is constructed of? And that's what I'm going to do. And I think there's something there. I feel like there's something there.
Yeah. No, I like that. Lean into it. And the other thing I'll say just about that is that, you know, if, I don't know what your beliefs are or whatever, but this is, you know, the one chance we get of like being conscious, like sandwiched between two eternities of nothingness, right? Like, let's try to get as much as we can get out of this experience. All right. You know, we have this little piece of matter, this brain that limits our ability to sort of understand the world around us. Like, we're seeing it all through this one organ. But whatever it allows us to see or think or contemplate, like I want to experience as much of it as I can, you know, with the good and the bad, right? The greater depth of experience I can have. I mean, if this is my one and only chance to just be conscious and experience things, then I want like the fullest gamut of it all. So I choose, you know, non-ignorance and with whatever that may come with, because that's the fullness of life.
That's really beautiful. What a wonderful way to finish. Heather, thank you so much.
Thank you.
When's your book going to be done?
Oh, that's a good question. So I'm writing it now, and it's due next year. So I'm hoping, optimistically, it's going to be the end of next year. The working title is The Fine Art of Losing Control.
That's cool.
So,
I like that.
Yeah, it's about sort of impulse control, when to rein it in, how to rein it in, is there any control really, and then when to let it go, and how letting go in a controlled way can counterintuitively allow you to gain more control.
That's cool. I'm looking forward to it.
Thank you.
Awesome.
Thank you.
People want to hassle you online, people want to find you, where should they go?
HeatherBerlin.com, and I'm on Twitter and Instagram at Heather_Berlin.
Lovely. Links will be in the show notes below. As always, if you've enjoyed it, like, share, subscribe, you know what to do. Any questions, comments, or feedback, just leave them in the comments on YouTube, and I'll send them over to Heather, and she can come and pop by and say hi or whatever it might be. But Heather, it's been awesome. Thank you so much.
Thank you so much.
Yeah,